Section 8.3, radians. Up to this point, we have only used degrees as units to measure angles. Another commonly used system is radians. In fact, radians are used way more than degrees. Degrees are generally taught first. They're a little easier to deal with, probably. But if you ever move up into calculus, you will only ever use radians. And there's a reason for that. There are really important things involved in calculus, like limits and derivatives and integrals, that only work in radians, whatever those things are. In the next section, we'll see several formulae that only work using radians. All right, so what is a radian? Well, here I've got a circle of radius 1. You can see radius 1. And I've got an angle marked where this arc right here, this arcs are typically called S, that arc is also length 1. If you have a circle of radius 1 and you have an angle where you have an arc of radius 1, then that angle is defined as 1 radian. So that's kind of nice in that you can clearly define 1 radian. You take a circle of radius 1, take an arc length of length 1, and that angle forms a 1 radian. Try to define 1 degree. Try to draw a picture that has 1 degree. It's really not very easy. Okay, so the important thing here is that if you have a circle of radius 1, the angle in radians is the same as the arc length. So that brings us to 2 really important angles. This angle is 360 degrees. That is the same, since this is a circle of radius 1, as the arc length of the circle. Well, that's the circumference of the circle. To find circumference, you might remember we use c equals 2 pi r, but since the radius is 1, the circumference is just 2 pi. So 360 degrees is exactly the same as 2 pi radians. Now notice when we write degrees, we always have to put a degree symbol on it. When we write radians, we don't typically put a unit on it, although sometimes you will see r like that, just to be super clear that it is radians, but typically we don't. All right, now we've got 180 degrees. 180 degrees would be half as much. So half away around the circle is 180 degrees. That's the same as pi radians. Okay. Well, that allows us to convert back and forth between the 2 systems. So if I start with 330 degrees and I want to convert it to radians, I'm going to multiply by something. I'm going to multiply that by the number 1. But it's going to look unusual. It's not going to look like the number 1. I'm going to use the fact that pi radians is the same as 180 degrees. So I have degrees on top, degrees on bottom. The degrees reduce out, and I'm left with radians. Now, be very, very careful when you write things from now on. If we are working in degrees, we absolutely need to write the degree symbol. If you write 180 and don't write a degree symbol, then that's 180 radians. Okay? So make sure you write the degree symbol all the time. All right, now what we do is we can reduce 330 over 180, but we recognize our answer is going to have a pi in it. So what I like to do is grab my calculator, go 330 divided by 180, and use it to convert and reduce the fraction for me. That's 11/6. So we write our answer as 11 pi over 6. And you'll get really used to that as we do more things with radians, that we type in the part without the pi, and then we just tag the pi on the end. All right, same thing here, 168 degrees. I want to get rid of degrees, so I put degrees on bottom. That's 180 degrees. I want radians, so I put pi on top. I grab my calculator. I go 168 divided by 180. Get my calculator to reduce that fraction, 14 over 15. And then I throw the pi back in. 14 pi over 15. Okay, going the other way. If I start with 3 pi over 4 radians, this time I want to get rid of radians, so I put radians on bottom. That would be pi down on bottom. And I want degrees, so I put 180 degrees on top. This time I notice that the pi's just reduce out, so I grab my calculator. 3 times 180 over 4. Give me a fraction, please. 135. And make sure you write that degree symbol. Okay, last one of these. 15 pi over 8. Again, I have radians. I want to get rid of radians, so radians goes on bottom and degrees go on top. The pi's reduce out. 15 times 180 over 8. Give me a fraction. Typed it in wrong. 15 times 180 over 8. Now give me a fraction. 675 over 2. Or maybe we don't want the fraction. I don't know. 15 times 180 over 8. Maybe 337.5 is better. Degrees. Don't forget your degree symbols. Okay, we had a list of very, very special angles back a while ago. You should know sine, cosine, and tangent for those very, very special angles using degrees. You should also know them using radians. Now, 0 degrees is 0 radians. That one's easy. 30 degrees, you would take 30 degrees, multiply by pi over 180, and you would find, when you reduce, you get pi over 6. And I'm not going to spend a lot of time showing you the rest of these. You can go and figure them out. This one turns out to be pi over 4, pi over 3, and pi over 2. So just like I should be able to ask you, what's the cosine of 45 degrees? And hopefully you've memorized that table and you tell me it's cosine 2 over 2. I'm sorry, the square root of 2 over 2. I should be able to ask you, what's the sine of pi over 4? And you should be able to tell me, well, that's square root of 2 over 2, because pi over 4 is the same as 45 degrees. All right, in our previous section, we talked about solving equations. We did it in degrees. So we're going to do this in degrees, and then we'll do it in radians. We'll do both. So the first thing I do is I go theta is sine inverse of 0.687. And I grab my calculator, sine inverse of 0.687. 43.4 degrees. Now remember, that's not the only answer. Remember, we've got this chart that we've been using. We know sine is positive in the first quadrant because all things are positive in the first quadrant. Sine is also positive in the second quadrant. So I need to come up with an answer in the second quadrant. Our reference angle is here, 43.4 degrees. We need that angle. So we take 180 degrees and we subtract 43.4 degrees. 180 minus 43.4 is 136.6 degrees. All right, now we're going to do the exact same problem, except we're going to use radians. Now, students will always ask me, well, couldn't I just take these answers and convert them to radians like we did up above? And the answer is, of course you could. But that's more time consuming, especially, I don't usually ask both where it's exactly the same. So what we're going to do, we're going to grab our calculator. We're going to change the mode to radians, because now we're working in radians. So theta is sine inverse of 0.687. I type that in just like I did before. Sine inverse of 0.687. I get 0.757 radians. That gives me the answer in quadrant 1, just like it did before. Now I got to find the answer in quadrant 2. So what happens now is we're looking for this angle just like we did last time, except our reference angle is now 0.757. And instead of using 180 degrees, we use pi radians. Pi radians, that's halfway around. And then we need to subtract the 0.757. 757, I mean. So it's exactly the same process. The difference is instead of 180 degrees, you use pi. Pi minus 0.757, 2.38. Oh, I should give it to 3 decimal places, I guess. 2.385. I gave this one to 3 decimal places. I'll give that one to 3 decimal places. All right, last problem. Same deal. First, we're going to go back 2 degrees. So you're going to get used to having to switch your calculator back and forth depending on the problem. If the problem wants degrees, make sure your calculator's in degrees. If it wants radians, make sure you're in radians. Tan inverse of negative 1.65. That's negative 58.7 degrees. Theta equals negative 58.7 degrees. All right, first problem we have is that's a negative angle, and we want positive answers. So we need the coterminal angle, which means we add 360 degrees. You know, I should have called that negative 58.8, shouldn't I? I'll fix that. Sort of. So 360 minus 58.8 is 301.2 degrees. Okay, so there's our answer in quadrant 4. Make this positive, and that's your reference angle. We're dealing with tangent being negative. Tangent negative in quadrant 4. We've got that. Tangent is also negative in quadrant 2. So I need an answer in quadrant 2 where my reference angle is 58.8 degrees. So that means my other answer is 180 degrees minus 58.8 degrees. $121.2 degrees. All right, same thing, except now let's put our calculator in radians mode. I would begin by doing tan inverse of negative 1.65. And it tells me it's negative 1.03. Can't have a negative answer, so we add 1 complete revolution to make it positive. So again, notice we're doing the same thing. We added 360 degrees here. Here we add 2 pi. 2 pi, 2 pi minus 1.03. That's 5.25. There's our answer in quadrant 4. And then drawing a picture, we need an answer in quadrant 2. We've got our reference angle of 1.03. So we got to go halfway around and then subtract that much. In radians, halfway around is pi. And then we subtract our reference angle. Pi minus 1.03. 2.11. Okay, so dealing with radians, dealing with this pi all the time is a little confusing. Takes a little time to get used to it, but with some practice, you'll have it all figured out.